We are on the section 8.5, page 27. We are going to talk about something called complex rational expressions. That means what? Complex fractions, right? So let's see. Polynomials on fraction forms are rational expressions, right? In a complex form, let's see, what do we mean by that? We say a complex fraction is what? A fraction whose numerator, denominator, or both contain one or more rational expressions. That means it's what? A fraction within a fraction. Okay? Let's see some examples. So, if we have a fraction like 1 over a, right? Rational expression, then another rational expression, then if we divide each other again, it becomes what? A fraction within a fraction. Things like that. Or it can be a fraction over another fraction. This one will have two terms, right, in the denominator. Or it might look like this, right? Rational expression and over another polynomial. So it becomes what we call a complex rational expression. So it's complicated. That's what it is, right? Then if we have this one, say 2x over 27y squared, a rational expression, right? Over another rational expression. It looks very complicated. So we want to write it in a simplest form. It means what? Just a simple fraction. One numerator, one denominator. How can we make it happen? Right? If we rewrite it this way, this line means what? A division, a divide, right? So if we rewrite this one like this, division over this, would that look much better? It becomes what? We will do the division between what? Two rational expressions, right? So we are doing what? Division. Add, subtract, multiply, and divide of what? Rational expressions. That what we were doing, right? That was what we were doing. So, how do we do division? We change division to multiplication. Multiply is what? Reciprocal, right? Then, before we multiply straight across, we will do what? Simplify it, right? Cross out the 3. Then 2 and 6 would be 3 here. How about x and x squared? So you cancel out 1, so you have 1 left. Then what do? We just do multiply straight across would be what? Y squared here. So it would be 9x squared, 9xy squared. Is that right? So it's not too bad, right? So if we have this one, second one, if we have 5x over x plus 2 divided by 10 over x minus 2, right? So what do? We rewrite it as what? A division. It looks much better now, right? Then what do? We change the division to what? Multiplication to its reciprocal, right? So don't cancel this x and x because we say what? It's a part of a group. The group should stay together. Put the parentheses around, right? So that's prime. Now anything we can cross cancel? Yes, 5 and 10, right? So that's the simplest one we can get. So that would be what? X times x minus 2, 2 times x plus 2. We can leave the answer just like that. We don't have to multiply them out because we can just leave them as a prime form, right? So let's write down the steps how we actually do it. So what do you think? First step, you will do what? Right? You will rewrite it as a what? As a division, right? Instead of writing in a complex form. Then we will do this as well. You want to make the top numerator and the denominator as simple as possible before you divide them, right? So you will simplify what? Dividend or the divisor. That means what? The numerator and the denominator, they are the same thing. Numerator and the denominator, right? So each one of them is as simple as possible. Each is what? A single fraction. Then we divide them, right? Then we also check to make sure it's correct. Then let's see how it's going to be, right? So if you look at the example 3, if you have x over y squared plus what? 1 over y divided by y x squared plus 1 over x. Even you write, so first we will write it like as a division, right? If you write it as division, like x y squared plus 1y divided by this. Because within the numerator or the denominator, you cannot directly flip becomes what? Multiplication, because when we do the multiplying the reciprocal, it has to be what? Single fraction. Right now, they are not a single fraction, so you cannot flip, you cannot cross cancel, right? So before we can flip, we have to do what? Make it each one as a single fraction. So within the complex fractions, you need to simplify each individual one first. Okay? So we wanted to make So within each complex fractions, and you might have what? Add, subtract, multiply, and divide, all the operations you need for the fraction things, right? So let's simplify them. So when we add them, what do we need to do? Right? Find the LCD, which is y squared, that's x, right? This one we need to multiply by what? Y. So that would be y over y squared. Now we have the same denominators, so we can put it together. Becomes what? A single fraction. So that would be a single fraction here, right? Then for the divisor, so we wanted to make it as a single fraction as well, which we will use LCD, right? For x squared, and x would be x squared. That would be y, and second one will be multiplying by x, right? Then what do we have? X squared, y plus x is the same thing as x plus y, right? 5 plus 3 equals 3 plus 5. They are the same. So we make the denominator as a single fraction as well. Then now we can divide, right? X plus y over x squared, right? So single fraction is divided by single fraction. Then what do? We just multiply its reciprocal, right? So before we multiply straight cross, we simplify them first. Can you cancel x and x? We say what? Don't do that, because it's a part of group which is a prime. You put the parentheses around. Okay? If you want to cross cancel, you have to do the whole group together, right? Then we can cross cancel. Then what do we have? We have x squared over y squared. Would that be much simpler than original complex rational expression? Is that right? So that would be your answer. Okay, let's see some more examples as well. Let's take a look on your page 28. And a situation like those. So for number 4, you have x negative 1 plus 2x y to the negative 1 power over negative 2 minus negative 2 y to the negative 1 power. Do you remember what does negative 1 power mean? So 5 negative 1, it is what? We say negative doesn't mean negative. It means what? It's just a symbol. It means a reciprocal. So that will be what? 5 over 1 to the 1 power. That will be 1/5, right? If 5 negative 2, it means what? 1 over 5 to the 2nd power. It means what? 1 over 25th, right? So let's take a look the x thing. So if x negative 1, it means what? 1 over x, right? X negative 2, it means what? 1 over x squared. What happened? If 2x negative 1, 2 is regularly regular 2, right? X negative 1 means what? 1 over x. So if you multiply regular 2, what do you think? How should we do it? For a fraction multiplication, you put a 1 underneath, you will be what? 2 over x. So whatever the variable with negative power, it means this one, you will use the reciprocal, right? But for the 2, even no negative powers, it means what? It stays the regular way. That will be on the numerator position, right? If you have 2, negative 2, so what should we have? Then we should have 2 over x squared, right? Because x negative 2 will be what? The reciprocal of x squared. Okay? So if we have, say, instead of 2x negative 1, we have 2x negative 1 whole thing, take the reciprocal. So what do you think you should do? So for the negative 1 power, and it applies to its base, which is 2x. So everything has to be reciprocal, right? That would be 1 over 2x. If you have 2x negative 2, what do you think? It should be 1 over 2x to the square, right? Whole thing is the base, take the reciprocal. So the final answer should be what? 1 over 4x squared. Is that right? So that's one with the number, one with the x variable. If you have both are variables, so if x negative 2 multiplied by y is regular, right? We say variables, letters mean numbers. So they behave the same way. So x negative 2, it should be what? 1 over x squared, right? If you multiply by y, you put a 1 underneath to multiply straight across. So you should have y over x squared. Is that right? So for the things you don't have a negative power, it should stay on the numerator position. Then the things with negative power, it should move to the denominator. So if you have x negative 2, y negative 1, what do you think? They both should move to what? To the bottom, right? So it should be x squared y. That means x negative 2, y negative 1, they move to the denominator, right? So that's basic operations for the negative powers. So if we have this situation, how should we start? We just change the normal way because we cannot see the negative powers. If we change it to what? Fractions, at least we can see a little bit of it, right? So let's do that. So what do we have? X negative 1 should be this one, right? Plus 2x, y negative 1. So y should be in the denominator. 2x should be stay on the top, right? Then x negative 2 will be 1 over x squared minus, right? Then this one will be what? 1 over x squared y. Is that right? Right? So first, we interpret the negative power. Then what do? We have a complex fractions. Then we say, what should we do with complex fraction? So rewrite it as a division, right? So we will rewrite it as division. Oops. Right? So we should do 1 over x plus 2x over y divided by 1 over x squared minus what? Right? Once we do that, we need to do what? Division. But we can only divide it. We can only divide things one fraction to another fraction. Right? So we have to make what? A single fraction, then divide. Is that right? So we have to make them as a single fraction. So how do we make this one as a single fraction? For adding them together, we need to do what? Finding the LCD, right? What's the LCD for this one? Should be xy, xy, right? And for this one, we need to multiply by y, that would be y. For this one, we need to multiply by x, that should be 2x squared, right? So we have same denominator, we can just combine the numerator. Right? So for the first fraction, we shall have 2x squared plus y divided by xy, right? Then for the second one, we shall have 1x squared minus x squared y, right? And to make it as a simple fraction, we need to do what? Use LCD, which is what? X squared y, right? And for this one, we need to multiply by y. This one is the same. Then we put them together. That will be x squared y, y minus 1. Is that right? So that would be x squared y, y minus 1. So both are a single fraction, right? Then we can do the multiplication and multiply its reciprocal. Oops, right? Reciprocal. So don't cancel the individual y, which is part of group. You better put a parenthesis around the binomial things, right? Is there anything we can cross cancel? Y, 1x, so you have 1x left, right? Then what do we have? Y minus 1, 2x squared plus y times x. So that would be your simplest form, okay? Or you can write a what? You can multiply them out. Either way, it's fine, okay? Q plus xy, y minus 1. Both would be fine. But usually we just leave it in the prime forms. So we know we cannot simplify anymore. Good? Let's look at the next one. 2x to the negative 1 power plus 1 divided by 2x negative 1 minus 1. So, what do you think? How should you start? Rewrite it without the negative exponents, right? because we cannot really see negative exponents. So we write them as a fraction form. For this one, 2x negative 1, that would be what? 1 over the whole thing, right? 2x plus 1. And this one, only x has negative 1, so x should move to the denominator position. 2 has no negative exponents. It should stay on the numerator position, right? Then what do? We will rewrite it as what? A division, right? Then, before we can divide and change division to multiplication, we have to make them as what? A single fraction, right? So for 1 over 2x plus 1, you need to make a single fraction by using the LCD, right? That's 1. This is a 2x, so that would be what? 2x plus 1. Is that right? So this one would be 2x plus 1 over 2x, right? Then for the next one, it should be what? Over 1, right? 2x minus what? Use x as a LCD, that would be x. So we should have what? x2 minus x, right? So that will be divided by 2 minus x to the x, right? Then we will write a what? Reciprocal times 2 minus x and x. You can change this to standard form. However, since this is a prime, this is a prime, nothing else there, we cannot cross cancel them. We can cross cancel the x. Then we can just leave as is, right? So that would be 2 times 2 minus x over 2x plus 1, okay? Or you can multiply them out. You write a what? 4 minus 2x and 2x plus 1. Either way, you can do that. Or you can write a what? Negative 2x plus 4 as a standard form. Okay? So we don't always have to use standard form, but by using standard forms, it helps us what? To cross cancel, because most of them will look alike. Okay, it's easier to identify them. But for the final answers, you can go either way. Okay, so are we good on complex rational expressions? To simplify them, right? It was kind of complicated. Then we simplify them to be what? Just a single fraction as an answer. So that would be our section 8.5.